stabilize the voltage to earth during normal operation as stated in the National Electrical Code section 250.4. A1 refers to maintaining a consistent and safe voltage level between an electrical system and the earth, also known as ground, while the system is operating under typical conditions. The purpose of this requirement is to mitigate the risk of electrical shock, prevent damage to equipment, and minimize other hazards that can arise from unstable or fluctuating voltage levels. In essence, it aims to ensure that the electrical potential difference between the system's conductive parts and the ground remains within acceptable limits, thereby promoting a safer and more reliable electrical environment. Several methods and devices are employed to achieve voltage stabilization. These include voltage regulators, surge protectors, and grounding techniques. Voltage regulators are designed to maintain a steady voltage output even when the input voltage or load current varies. They work by actively adjusting the voltage to compensate for fluctuations, ensuring that connected equipment receives a consistent and stable power supply. Surge protectors, on the other hand, are designed to protect equipment from transient voltage spikes such as those caused by lightning strikes or power surges. They divert excess voltage away from sensitive equipment, preventing damage. Grounding is a fundamental safety measure that involves connecting the electrical system to the earth through a low impedance path. This provides a reference point for voltage and helps to dissipate fault currents, reducing the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding, including the size and type of grounding conductors, the methods for connecting to ground electrodes, and the bonding of metallic enclosures and equipment. When designing and installing an electrical system, it is crucial to adhere to the requirements of the NEC to ensure that the voltage to earth is properly stabilized. This includes selecting appropriate voltage regulators and surge protectors, properly grounding the system, and regularly inspecting and maintaining the system to identify and address any potential issues. By taking these measures, you can help to create a safer and more reliable electrical environment for yourself, your employees, and the public. Maintaining a stable voltage to earth during normal operation is a critical aspect of electrical safety and reliability. By understanding the principles and techniques involved, and by following the requirements of the NEC, you can help to prevent electrical shocks, equipment damage, and other hazards. The stabilization of voltage to earth is crucial for several reasons. Firstly, it minimizes the risk of electrical shock. If the voltage to earth is unstable or too high, it can create a dangerous potential difference between the electrical system and the ground, increasing the likelihood of electric shock if someone comes into contact with a live part of the system. Secondly, it protects equipment from damage. Voltage fluctuations can damage sensitive electronic equipment, causing it to malfunction or fail prematurely. By stabilizing the voltage, you can extend the lifespan of your equipment and reduce the need for costly repairs or replacements. Thirdly, it improves the overall reliability of the electrical system. Unstable voltage can cause erratic behavior in electrical equipment, leading to system downtime and disruptions. By stabilizing the voltage, you can improve the stability and reliability of the system, reducing the risk of interruptions. The NEC provides specific requirements for stabilizing the voltage to earth. These requirements are designed to ensure that electrical systems are installed and operated safely. Section 250.4. A1 of the NEC states that the electrical system shall be grounded in a manner that will limit the voltage to ground on exposed non-current carrying metal parts of equipment. This means that the system must be connected to earth through a low impedance path to prevent the buildup of dangerous voltages. The NEC also requires the use of grounding electrodes such as ground rods or ground plates to provide a reliable connection to earth. The size and type of grounding electrode required depends on the size of the electrical system and the soil conditions. In addition to grounding, the NEC also requires the use of bonding to connect all non-current carrying metal parts of equipment together. Bonding ensures that all metal parts are at the same electrical potential, reducing the risk of electrical shock. The NEC provides specific requirements for bonding conductors, including the size and type of conductor required. Voltage regulators are devices that are used to maintain a stable voltage output. They work by automatically adjusting the voltage to compensate for fluctuations in the input voltage or load current. Voltage regulators are commonly used in sensitive electronic equipment, such as computers and medical devices, to ensure that they receive a stable power supply. Surge protectors are devices that are used to protect equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other events. Surge protectors work by diverting excess voltage away from sensitive equipment, preventing damage. Surge protectors are commonly used to protect computers, televisions, and other electronic equipment. Grounding techniques involve connecting the electrical system to the earth through a low impedance path. This provides a reference point for voltage and helps to dissipate fault currents, reducing the risk of electrical shock. Grounding is typically achieved by connecting the neutral conductor of the electrical system to a grounding electrode, such as a ground rod or ground plate. The grounding electrode is then connected to the earth. There are several types of grounding systems, including solidly grounded systems, impedance grounded systems, and ungrounded systems. Solidly grounded systems are the most common type of grounding system. In a solidly grounded system, the neutral conductor is directly connected to the earth. Impedance grounded systems use a resistor or inductor to limit the ground fault current. Ungrounded systems do not have a direct connection to earth. When designing and installing an electrical system, it is important to consider the specific requirements of the NEC and the local electrical codes. These codes provide detailed requirements for grounding, bonding, voltage regulation, and surge protection. It is also important to consult with a qualified electrical engineer to ensure that the system is designed and installed safely and effectively. Regular inspection and maintenance of electrical systems are essential for ensuring their continued safety and reliability. Inspection should be conducted by qualified electricians who are familiar with the NEC and local electrical codes. During inspections, electricians should check for any signs of damage or deterioration, such as frayed wires, loose connections, or corroded components. They should also test the grounding system to ensure that it is functioning properly. Maintenance activities should include cleaning electrical equipment, tightening connections, and replacing any worn or damaged components. It is also important to keep electrical panels and equipment clear of obstructions to allow for easy access and ventilation. By following these guidelines, you can help to ensure that your electrical system is safe, reliable, and compliant with the NEC and local electrical codes. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. Stabilizing the voltage to earth involves a combination of grounding, bonding, and the use of appropriate protective devices. Firstly, grounding provides a lower impedance path for fault currents to return to the source, helping to trip circuit breakers or fuses quickly in the event of a ground fault. This minimizes the duration of the fault and reduces the risk of electrical shock. Secondly, bonding ensures that all metallic parts of the electrical system are at the same potential, preventing voltage differences that could cause electric shock. This includes bonding equipment enclosures, metal raceways, and other metallic components. Thirdly, protective devices, such as surge protectors and ground fault circuit interrupters, commonly known as GFCIs, play a crucial role in protecting against voltage surges and ground faults. Surge protectors divert excess voltage away from sensitive equipment, while GFCIs detect ground faults and quickly interrupt the circuit, preventing electrical shock. Stabilizing the voltage to earth is not only a matter of safety, but also a matter of compliance with the NEC. The NEC provides specific requirements for grounding, bonding, and the use of protective devices. Failure to comply with these requirements can result in fines, penalties, and even legal action. To ensure compliance, it is essential to have a thorough understanding of the NEC requirements and to follow them carefully when designing and installing electrical systems. It is also important to have electrical systems inspected regularly by qualified electricians to ensure that they are in compliance with the NEC. Stabilizing the voltage to earth is a continuous process that requires ongoing monitoring and maintenance. Electrical systems should be inspected regularly for any signs of damage or deterioration. Grounding and bonding connections should be checked to ensure that they are tight and corrosion-free. Protective devices should be tested periodically to ensure that they are functioning properly. By taking these steps, you can help to ensure that your electrical system remains safe and compliant with the NEC. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. The concept of stabilizing voltage to earth is deeply rooted in electrical safety principles. It's not simply about adhering to codes, but about creating an environment where the risk of electrical hazards is minimized. This involves a multi-layered approach, starting with a solid understanding of grounding and bonding techniques. Grounding provides a reference point for the electrical system, ensuring that the voltage to earth remains within safe limits. This is achieved by connecting the neutral conductor of the system to a grounding electrode, which is typically a metal rod driven into the earth. The grounding electrode provides a low impedance path for fault currents to return to the source, allowing protective devices to quickly trip and de-energize the circuit. Bonding, on the other hand, focuses on eliminating voltage differences between metallic parts of the electrical system. This is accomplished by connecting all metallic enclosures, raceways, and equipment together with bonding conductors. By ensuring that all metallic parts are at the same potential, the risk of electric shock is significantly reduced. In addition to grounding and bonding, surge protection is another important aspect of stabilizing voltage to earth. Voltage surges caused by lightning strikes or switching transients can damage sensitive electronic equipment and pose a safety hazard. Surge protective devices, SPDs, are designed to divert these surges away from equipment, protecting it from damage. SPD are typically installed at the service entrance of a building and at branch circuit panels to provide comprehensive surge protection. Ground fault circuit interrupters, GFCIs, are another essential safety device that plays a critical role in stabilizing voltage to earth. GFCIs are designed to detect ground faults, which occur when current leaks from a circuit to ground. When a ground fault is detected, the GFCI quickly interrupts the circuit, preventing electric shock. GFCIs are typically installed in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. The National Electrical Code, NEC, provides comprehensive requirements for grounding, bonding, surge protection, and GFCI protection. These requirements are designed to ensure that electrical systems are installed and operated safely. Compliance with the NEC is essential for protecting people and property from electrical hazards. Stabilizing voltage to earth is a fundamental principle of electrical safety. It involves a combination of grounding, bonding, surge protection, and GFCI protection. By understanding and implementing these principles, you can create a safer electrical environment for yourself and others. Always consult with a qualified electrician when working with electrical systems. They have the knowledge and experience to ensure that your electrical system is installed and maintained safely and in accordance with the NEC. Ongoing education and training are crucial for staying up to date on the latest electrical safety practices and technologies. The electrical industry is constantly evolving, and it is important to stay informed about new developments. By investing in education and training, you can enhance your skills and knowledge and improve your ability to provide safe and reliable electrical services. The goal of stabilizing voltage to earth during normal operation, as outlined in NEC 250.4. 8.1, is to ensure a safe and reliable electrical system by maintaining a consistent and predictable voltage level between the electrical system and the earth. This is achieved through a combination of proper grounding, bonding, and overvoltage protection. Let's break down the components and their significance. Grounding establishes a reference point for the electrical system with respect to the earth. This reference point helps to limit the voltage on exposed non-current carrying metal parts of equipment, reducing the risk of electric shock. The grounding system typically consists of a grounding electrode, such as a ground rod or a ground plate, connected to the system's neutral conductor at the service entrance. Bonding connects all non-current carrying metal parts of the electrical system together, creating a low impedance path for fault currents to flow back to the source. This ensures that all metal parts are at the same electrical potential, minimizing the risk of electric shock if someone comes into contact with a live part of the system. Overvoltage protection devices, such as surge protectors, are used to protect equipment from voltage spikes caused by lightning, power surges, or other transient events. These devices divert the excess voltage away from sensitive equipment, preventing damage. The NEC provides detailed requirements for grounding, bonding, and overvoltage protection. These requirements are designed to ensure that electrical systems are installed and operated safely. Section 250 covers grounding and bonding requirements, while Article 280 addresses surge protection. When designing and installing an electrical system, it is important to carefully consider the grounding, bonding, and overvoltage protection requirements of the NEC. A qualified electrical engineer or electrician can help to ensure that the system is properly designed and installed. Regular inspection and maintenance of electrical systems are essential for ensuring their continued safety and reliability. Grounding and bonding connections should be checked to ensure that they are tight and corrosion-free. Overvoltage protection devices should be tested periodically to ensure that they are functioning properly. By following these guidelines, you can help to ensure that your electrical system is safe, reliable, and compliant with the NEC. The stabilization of voltage to earth is a multifaceted concept that extends beyond simply grounding the electrical system. It encompasses a range of techniques and practices designed to ensure a safe and reliable electrical environment. Firstly, grounding provides a low impedance path for fault currents to return to the source, allowing protected devices to quickly trip and energize the circuit. This minimizes the duration of the fault and reduces the risk of electrical shock. Secondly, bonding connects all non-current carrying metal parts of the electrical system together, creating an equipotential plane. This means that all metal parts are at the same electrical potential, preventing voltage differences that could cause electric shock. Thirdly, surge protection devices, also known as SPD, are used to protect equipment from voltage surges caused by lightning, power surges, or other transient events. These devices divert the excess voltage away from sensitive equipment, preventing damage. Fourthly, ground fault circuit interrupters, GFCIs, are used to protect people from electric shock. GFCIs detect ground faults and quickly interrupt the circuit, preventing a dangerous current from flowing through a person's body. The NEC provides detailed requirements for grounding, bonding, surge protection, and GFCI protection. These requirements are designed to ensure that electrical systems are installed and operated safely. It is important to note that the NEC is a minimum standard, and in some cases, it may be necessary to exceed the NEC requirements to ensure adequate safety. For example, in areas with high lightning activity, it may be necessary to install additional surge protection devices. Similarly, in areas with sensitive electronic equipment, it may be necessary to use a more robust grounding system. When designing and installing an electrical system, it is important to consult with a qualified electrical engineer or electrician to ensure that the system is properly designed and installed. They can help to assess the specific needs of the application and recommend the appropriate grounding, bonding, surge protection, and GFCI protection measures. Regular inspection and maintenance of electrical systems are essential for ensuring their continued safety and reliability. Grounding and bonding connections should be checked to ensure that they are tight and corrosion-free. Surge protection devices should be tested periodically to ensure that they are functioning properly. GFCIs should be tested monthly to ensure that they are working correctly. By following these guidelines, you can help to ensure that your electrical system is safe, reliable, and compliant with the NEC. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. The stabilization of voltage to earth is not a static concept, but rather a dynamic process that requires ongoing monitoring and maintenance. Electrical systems are constantly subjected to various stresses such as changes in load, environmental conditions, and aging of components. These stresses can affect the performance of the grounding, bonding, surge protection, and GFCI protection systems. Therefore, It is important to regularly inspect and maintain these systems to ensure that they are functioning properly. Inspection should include a visual examination of all grounding and bonding connections to check for corrosion, looseness, or damage. Surge protection devices should be tested to ensure that they are still capable of diverting excess voltage. GFCIs should be tested monthly to ensure that they are tripping correctly. In addition to regular inspections, it is also important to perform periodic testing of the grounding system. This testing can be performed using a ground resistance meter, which measures the resistance of the grounding electrode to earth. The measured resistance should be within the acceptable limits specified by the NEC. If the resistance is too high, it may indicate a problem with the grounding electrode or the grounding connections. In such cases, it is necessary to take corrective action to improve the grounding system. The stabilization of voltage to earth is an essential aspect of electrical safety. By understanding the principles and practices involved and by following the requirements of the NEC, you can help to create a safer and more reliable electrical environment for yourself, your family, and your community.